Hey everyone, welcome back to my YouTube channel. In today's video, we are going to solve one of the most popular coding problem, two-sum. This problem is so common that it is the often first question asked in interviews to test our problem solving skills. Over LeetCode, it is the first problem with name two-sum. It is described as given an array of integers nums and an integer target. Return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Now let's understand this problem. Now, as described in our problem, let's assume an array nums with some integer values. For example, we have values 2, 7, 11 and 15 and a target value equals to 9. Now we are asked to find two indices from the nums array such that the value over these indices add up to the target value. Now we can see in nums array we have integers 2, 7, 11 and 15, and if we add the value over index 0, that is 2, and the value over index 1, that is 7, this will be equals to 2 plus 7 equals to 9, which will be totally equals to the target value, which is 9 here given. So we have to return the index over where these values are present, 2 and 7. So we can see the 2 is present over the 0th index and 7 is present over the 1 index. So our output will be 0 and 1. This is what we have to do in this problem. Now, after understanding the problem, the first basic solution, or we can say the brute force approach that hits our mind is, I think, using two pointers, or we can say using two for loops. In this approach, we will initialize a pointer at first index, that is index 0, and initialize a pointer at index 1. Now we will iterate the second pointer till last and add the values at both the pointers. And if the value is equal to the target value, then we will return the indices of both the pointers. For example, now moving towards our code, we can see that we have initialized an integer type n variable which will store nums.length value. In our case, the length of nums array is 4. So the initial value at n will be 4. In second row, we have initialized an integer type array named as answer which will store only 2 values. In third line, we have started a for loop starting from 0 and ending at the n minus 1 value. But why we have used n minus 1 value? As we are starting another for loop for the next value of I, and if we reached the last value of nums for I, then how we will start our next jth loop if, as our arrow have ended here, we cannot start our next for loop. So we have used n minus 1 value. So our I pointer will start from 0 and till it will iterate till n minus 1 values from here to here. Now for each value of I, we have another for loop starting with I plus 1 value. Let's assume our ith pointer is here, somewhere at 0th index. Then our jth pointer will always start from the I plus 1, that is 1 index, and it will iterate till all the values of the array. And now we will check the sum of these two pointers if equals to the target value. Our will be checked using if condition. And now if the sum at both the pointers is equal to the target value, then we will add the first pointer at the 0th index of our resultant array, that is answer, and we will add the jth index at the first position of the our resultant array, that is answer, as we can see here. Now this is the process, the easiest process following which we can solve this problem very easily. The code for the brute force approach. In our brute force approach, we have used two pointers. So it will have the time complexity of n square. We have used. Let's try to reduce this time complexity using optimal approach. We can reduce this time complexity using HashMap. So we have, in our first line of code, we have created a HashMap named as map, which will store two integer values. Now we will start a for loop from the first index of the nums array, and it will end at the last index of the array. And for each value, it will create an integer complement integer value, which will store the value of target minus nums I. For example, when the I is at 0 index, it will have value 2, that is target minus nums I. The target is 9 minus nums I equals to 2, then it will give 7. The integer complement will have the value 7. And now if it will check if map dot contains key complement, the meaning of this line is, if we have this complement in our hash table, next value, that is first iteration, we don't have any value in our hash map, so we will not enter in this if condition, and we will go for the next line, that is map dot put nums I and I. What does this line means? This line means we will put the values at nums I, that is the value in the nums array at ith index and the index I in our hash map. So for the first iteration, it will put 2, 0 in the hash map, and now again the value of I will increase and it will reach to the 1, that is index 1, which will have the value 7. Now again it will create the complement, but now this time the complement will be 9, that is target minus the value at index I, that is 7, which will equals to 2, and the complement value this time will be 2. Now it will check if this complement value is present in our hash map. It will answer as yes. Here we can see here the value is present in our hash map. So what will we do? It will return an integer type array, which will have the map dot get complement, means the value at the map at complement, which is complement is 2 and the value at it will be 0, that so it will return 0, and I is here 1. So this line will return these two values in an array. This is what we are doing in our optimal approach. It will have the time complexity of only n, big O of n, which is very less than big O of n square. So we have reduced the time complexity using our optimal approach.